If we know the slope of a line, and we also know the point at which it crosses the y-axis, which is called its y-intercept, we can write the equation of that line in slope-intercept form. On the graph shown here, we see a line that has a slope of 2/3 and crosses the y-axis at 0, -3, so its y-intercept, b, is -3. Using slope-intercept form, y equals mx plus b, we can then write the equation of the line. The equation of our line is y equals 2/3 x minus 3. Let's suppose we want to find the equation of the line with slope m equals 1/2 that contains the point 2, 3. The first thing you need to notice is that the point 2, 3 is not on the y-axis. We know that because if it was on the y-axis, its x-coordinate would be 0, not 2. So in this problem, 3 is not the y-intercept, so we're not going to go directly to slope-intercept form. There's another important equation of the line that's called point-slope form that's perfect for this situation. The point-slope form equation of a line, where the line has slope m and passes through a point x1, y1, is y minus y1 equals m times x minus x1. In our example, m equals 1/2, and the x1, y1, the point that the line passes through, is the point 2, 3. So the equation of our line in this problem is y So the equation of our line is y minus 3 equals 1/2 times the quantity x minus 2. If we want to put this back into slope-intercept form, we simply solve this for the variable y, and we end up in the form y equals mx plus b. Suppose we want to write the equation of the line that contains the points -1, 4, and 6, 8. We've got plenty of points. All we need is one point to write the equation of the line, but what we're missing at the start is the slope. So the first thing we have to do is use the slope formula to find the slope of this line. The slope of a line is given by y2 minus y1 over x2 minus x1, where the 2 points are x1, y1 and x2, y2. So in our example, we're going to take the y-coordinates, 8 minus 4, subtract those, and divide it by the x-coordinates subtracted, 6 minus a -1. So we get a slope of 4/7. Now, since neither point that we were given is a y-intercept, and again we know that because their x-coordinates are not 0, we're going to use the point-slope form of the equation of the line to get its equation. I know the slope is 4/7, and I can use either point I want for x1, y1. So I'm going to use x1, y1 to be the point 6, 8. And again, it didn't matter which one I chose. Okay, so the equation of our line in point-slope form is y minus the y-coordinate, 8, is equal to the slope, which is 4/7, times x minus the x-coordinate, which is 6. On our next slide, we'll show how to convert this equation into slope-intercept form in case that's what we'd like to have. As a last step, suppose we want to convert the line that we got on the previous page, y minus 8 equals 4/7 times x minus 6, into slope-intercept form. That means that we're just going to solve this equation for the form y equals mx plus b. As a first step, we could distribute the 4/7. Yeah, I take that back. As a first step, I'm going to elect to multiply by 7 and therefore get rid of all of the... No, I'm not. Ha! Okay, that's embarrassing. Well, as a comment, either method would be fine. Multiplying by 7 avoids fractions, but you have to divide back at the end. Multiplying by 4/7 makes you work with fractions. It's strictly the choice of the user. Okay, so we have to make a decision. And I will go with plan B. I'll multiply everything by 7. If we multiply both sides of this equation by 7, we get 7y minus 56 equals, and on the right side the 7 will cancel the 7 in that denominator, so we'll have 4 times the quantity x minus 6. Now we can distribute 7y minus 56 is equal to 4x minus 24. Okay, if we add 56 to both sides, we'll get that 7y is equal to 4x plus 32. Now dividing every term by 7 will give us y equals 4/7 x plus 32 over 7. So our line has slope 4/7. We knew that from a long time ago, and its y-intercept is 32 over 7.